Hello and welcome back. Today we get to work with section 2.5 on factoring quadratic expressions. So first we'll look at what it takes to be a quadratic expression and then a quadratic equation. So a quadratic expression is an expression that can be expressed So can be, not must be, can be expressed in the form ax squared plus bx plus c. So it's not necessarily in this order. It might have multiple x squared terms or multiple x to the first terms. A, B, and C here are in the set of real numbers. However, A is non-zero. A cannot be the real number 0. Otherwise, 0 times any number is 0. That would drop the entire term, and we would be looking at a linear expression, not a quadratic expression. Similarly, a quadratic equation we have to have the ability to get it to the form ax squared plus bx plus c equals 0. Again, it's not necessarily going to be starting off in that form. We just have to have the ability to get it there. So same rules as above. A, B, and C are elements of the set of reals. A is non-zero. One thing that's useful in equations is to check if something is a solution. So we'll check is x equals -3 a solution to, let's see, we'll do 4x squared minus 1 is worth 2x plus 41. So this one doesn't look exactly like this, but it does still qualify as a quadratic equation. All I would have to do is use the addition property of equality to move the 2x and the 41, and we would be able to set it to 0, and we would have a second power with a non-zero coefficient. We happen to also have a first power and a constant, but we don't have to have those. B and C are allowed to be 0 for that. So to check if that works, substitution's the name of the game. Everything that used to be an x is now set up parentheses. So everything else comes along, everything that was an x, now a set of parentheses. And then we just go back through and fill in the value they're asking about. So a -3, a -3. Since we don't know if this equation is true, we can't use the properties of equality to move things around. We just simplify as much as we can. So order of operations on the left-hand side, no grouping symbols. We have parentheses, but no operations inside of them. Exponents and roots, we do have an exponent. So -3 times -3 is +9. So we have 4 by 9 minus 1. And we want to know, is that equal to? So I'm putting a little question over our equals. We don't know if it's true or false. Possibly equal to right-hand side, no grouping symbols, no exponents or roots. So on to multiplication or division from left to right, and we do have a multiplication. Okay, on the left-hand side, no exponents or roots left, so multiplication, division from left to right, we do have a multiplication problem. And we only have one operation left on the right-hand side, addition, so we'll take care of that. And 35 equals 35. We get a true statement out of it. If it's true, the answer to is this a solution is yes. If we had a statement that was nonsense, 35 is equal to 24, No, it's not a solution then. So the different thing about quadratics versus linear equations is that we can have more than one solution. We saw that in our absolute values as well, is that it introduces the possibility of multiple solutions to a single equation. So next I want to do just a little bit of practicing, making sure we're good with identifying if something is or is not quadratic. So we'll go back to expressions. So I'll introduce an expression. We'll decide, is this a polynomial? And if it is it quadratic? So we'll look at maybe x squared minus 6x plus 94. So here a is worth 1, b happens to be negative 6, c happens to be 94. A is non-zero. Our variable is raised to at most the second power. So this is a polynomial. We'll just say yes. And this also is quadratic because the leading degree is 2, as opposed to x to the fourth minus 7x squared plus 3x plus 2. This is still a polynomial. So polynomials, hopefully you remember from your previous coursework, exponents are whole numbers only. However, this is a definite no for quadratic. Leading exponent is a 4, not a 2. This one also, yes, it's a polynomial. It looks like it would be quadratic, but notice we have the additive inverse property here. We would have a leading coefficient of 0. A is not allowed to be 0, so this one is not quadratic. 7x minus 2 over x plus 3. This one is not a polynomial. So you might say, okay, I don't see any whole number, non-whole number exponents. Well, recall that by exponent rules, 1 over a is worth a to the negative first. So this is really an x to the negative first attached to that 2. That's why this is not a polynomial, and if it's not a polynomial, it can't be a special kind of polynomial. Similarly, for 8x to the 1/2 plus 2x plus 3, x to the 1/2 is the same thing as square root of x. So in either this form or this form, these two are equivalent. Both of these are a no for the polynomial, so no for the special kind of polynomial. So whether we see a square root or a fraction for a power, that kicks it out of being a polynomial. So variables and denominators, variables under radicals. We're no longer in polynomial territory. And to be a quadratic, then we're looking at polynomial that is of degree 2. So we look at doing some factoring once we have a quadratic. So we're just going to use kind of a basic method each time. We're going to get to ax squared plus bx plus c order. If we don't start out in the form, just use the commutative property of addition to get yourself there. So you're going to find the value for a times c. You're going to find the value for b. Then we look for two integers with product of AC and sum of B. Rewrite the middle term. We'll see how in the examples. And then it's distributive property from there. So we'll start with x squared minus 13x plus 40. And we're looking to factor. So here a is 1. If I don't write the coefficient of a term, it's assumed to be a 1. B is negative 13 and C is 40. So notice the signs also have to come along. B is not 13, B is negative 13. So then A times C, 1 times 40 is 40. So I'm going to make a little table for the factors of 40. Now, as far as signs, some hints for the sign work. If the product is positive, and we're looking again just for two integers, so either plus plus or minus minus, you just check B to decide which one. If the product is negative, you have one of each sign. And the bigger absolute value shares B's sign. So these are some good hints to look for as far as sign work. So our product here is positive, so it's either going to be plus plus or minus minus. The fact that B is a negative tells me to make everybody in this a negative. So negative 1 and negative 40, product of 40, but a sum of negative 41, we wanted a sum of negative 13. These, I also find it easier to go in order. Start with one and build up from there. And then you can stop working once you find the correct B term. So negative 2 and negative 20, that will multiply to 40, but it adds to a negative 22. We're looking for a negative 13. 3 doesn't work. A quick check for divisibility rules with 3. Add up the digits. If the sum is not divisible by 3, the bigger number is not divisible by 3. So 4 plus 0 is 4. 3 doesn't go into 4. 4 is a factor of 40. We're getting closer. Sum of negative 14. It ends in a 0 or a 5. So 5 is a factor, and negative 5, negative 8. There's our winning combo. So I could keep looking at the 6, the 7, but I've got my winning combination here. So we got it into the right format. It was already there. We found AC, and we already had B. We found our two integers with product AC and a sum of B. So rewriting the middle term, I'm going to keep the first exactly how it was, but where I used to have this minus 13x, I'll use these as coefficients on my first power. So I'll call it minus 5x minus 8x and bring down my plus 40. So after that, we've now rewritten the middle term, distributive property. So common factor of these first two terms is x. We'll pull the x, leaving us an x minus 5. Common factor of these next two terms is either an 8 or a negative 8. We'll pull the negative 8. You'll know that you picked the right combination when you see the same factor appear both times. Then we just use the distributive property one more time. This is now a factor of two terms. Here's one term, here's another term. Pull that common factor, x minus 5 by x minus 8. When the leading coefficient is 1, we can actually skip. Notice these match. This works only for a equals 1. Once you find your two numbers, you can just skip to that factored version. That does not work if a is anything other than 1. Okay, so next up, let's try out 8x squared minus 14 times x minus 15. So again, they're asking for us to factor. I don't see the wrong order here. It's second power, first power constant, so we're good there. No GCF other than the trivial 1. So we'll identify our A, our B, and our C. So A is 8, B is negative 14, C is negative 15. So 8 by negative 15 is the same as 4 by negative 30. So negative 120. And B is the negative 14. So I'll make my table for the product. And again, we just go in order. So here, as far as sign work, AC is a negative, so I know it's one of each. The fact that B is a negative says that the big absolute value is negative. So this will be a positive 1 with a negative 120. Right product, wrong sum. Sum of negative 119. 2 and negative 60. We're getting closer. We're at negative 58 now. 3 is definitely a factor. 1 plus 2 plus 0 is 3. 3 goes into itself. So 3 and negative 40. Negative 37. So we're getting closer. Last two digits are divisible by 4, so the whole number is divisible by 4. So 4 and negative 30. So sum of negative 26. So we're zeroing in on it. We're getting closer. Ends in a 5 or a 0, so 5 is a factor. 5 will go into 12 twice with 2 left over. 5 goes into 20 4 times. And negative 19, we're still getting closer. Not quite there yet. 6 and negative 20. There's our winning combination. So even though there are more numbers that we could use, we stop once we hit the correct sum. So we found our winning combination. So I will keep the 8x squared, I'll keep the minus 15 at the end, but this minus 14x, I'm going to split it up. I'm going to rewrite the middle term into a plus 6x and a minus 20x. Then we're just factoring using the distributive property. Common factor of 8x squared and 6x is 2x. So we'll pull a 2x. 2x by 4x gets us back to 8x squared. 2x by positive 3 gets us to positive 6x. Negative 20, negative 15. We'll just use this guy's sign of a negative. 5 is a factor of each one of those. So negative 5 times positive 4x is negative 20x. Negative 5 by positive 3 is negative 15. And now we see we did do it the right way since we see the same factor appearing on both of these. So then it's just one more use of the distributive property. So we'll pull a 4x plus 3, leaving us with a 2x and a minus 5. Okay, let's try another one. Let's do a 6x squared minus 17x and a plus 12. GCF is still 1. If the GCF isn't 1, just take care of that. We'll see an example for that later. So A is 6, B is negative 17, C is positive 12. So A times C, 6 times 12, positive 72. B is negative 17. So our product is positive. So this tells me it's either plus plus or minus minus. The fact that B happens to be a negative, that tells me to use the minus minus when I make my table. So I'll make my table of 72. Everybody gets a negative. So negative 1, negative 72, negative 2, negative 36, negative 3, negative 24, negative 4, negative 18. 5 doesn't work. It doesn't end in a 0 or 5. 2 and 3 work, so 6 has to work. So far, we don't have the right sum yet, though. Negative 73 for a sum, negative 38 for a sum, negative 27 for a sum, negative 22 for a sum, and negative 18 for a sum. So 7 is not a factor, 8 is a factor, and negative 8, negative 9, there's our winners. So like before, I'll keep the 6x squared, I'll keep the plus 12, but we're going to rewrite the minus 17x as minus 8x, minus 9x, and I'm going to ask you to pause the video there and see if you can finish this factoring by grouping. Okay, welcome back. So our first two terms, hopefully you spotted both a 2 and an x in common. So we have a 3x and we have a minus 4. The negative 9 and the positive 12, we will use this guy's sign and pull a negative 3. So negative 3 by positive 3x is negative 9x. Negative 3 by negative 4 is positive 12. And then there's our common factor again. Distributive property one more time. So 3x minus 4 by 2x minus 3. So next we want to know, okay, well, what if the GCF is not a plain boring one? Well, the answer is sort of similar to what we had when we were looking at the absolute value equations, and we said, okay, is the absolute value by itself? If the answer was no, our response was fix that. So similar here. If the GCF isn't 1, fix it. Pull the GCF. So we factor the GCF, then we proceed as we'll start with just a plain boring one variable GCF. So x cubed plus 4x squared minus 21 times x. So the GCF isn't 1, fix that. So our GCF here is x, pull that common factor. So we have x by x squared plus 4x minus 21. For the rest of the problem, we just keep this x, don't lose him. There, he's saying, keep me, don't lose me. He can't disappear and reappear later on. Keep that factor going. So the rest of it we proceed as before. So we'll identify, since this is a quadratic, a second power, first power constant. So here a is 1, so we can use the fast factoring. B is 4, and C is negative 21. So AC is negative 21, B is positive 4. So the fact that our product is a negative tells me we have one of each sign. The fact that B is a positive tells us the big absolute value is positive. So the little guy is negative. So we'll make our table for negative 21. So big guy gets positive, so the little guys are negative. So negative 1 and 21 sum to a positive 20. It's not even, so 2 won't work. Negative 3 and positive 7, and there's our winning combination. And because A is equal to 1, this tells me we can use, I refer to it loosely as fast factoring. So I keep this x, and we'll just jump right to our 2 sets of parentheses, x at the front of each line, and a minus 3, and a plus 7. If you want to check that that's correct, FOIL this out, look at your like terms, and you should see you get back to this stage, distribute this, and you'll get back to the original. So now this is fully factored. Okay, this next one starts off looking a little messy, but again, we can make it a little bit simpler. So we'll do a negative 6x squared plus 6x plus 180. So here, GCF is definitely not 1. We can use a 6 or a negative 6 because the leading one is negative. We'll use a negative there, and 6 goes into each one of these guys. GCF is negative 6. So negative 6 by x squared, minus 1x or minus x, and then negative 6 by negative 30 is positive 180. Now, just like that x before, don't lose them. Keep me. Don't lose me. So this negative 6 is always going to be along for the ride for the rest of that problem. So now our a is 1, so we can do the fast factoring. B is negative 1, and C is negative 30. So we're looking for a product, a times c of negative 30, and a sum, b, of negative 1. Go ahead and pause it if you need to. See if you can figure out what the two integers are that will get that job done. So hopefully you found that the two integers for that we're looking for one of each sign. So a negative 30. And our bigger absolute value was a negative. So 1 and negative 30, negative 29, no. 2 and negative 15, sum of negative 13. 3 and negative 10, negative 7, we're getting closer. 4 doesn't work. 5 and negative 6, and there's our negative 1. So hopefully you found your 5 and negative 6. Since our a is now worth 1, now that we've grabbed our GCF, a is 1 for the inside stuff, we can use the fast factoring. So x plus 5 by x minus 6. So they'll multiply to negative 30, add to a negative 1. Okay, so let me have you all try one out. So we'll do a little student try one. You're going to factor, let's see what I pick for this one. Negative 15x squared plus 55 times x plus 20. I'll give you a hint. The GCF is definitely not 1. So pause it, play it when you're done. Okay, welcome back. So the GCF, negative 5, will go into all of these. So we pull the GCF first. So negative 5 by 3x squared gets us back to negative 15x squared. Negative 5 by negative 11x gets us back to positive 55x. And negative 5 by negative 4 gets us back to a positive 20. So A is now 3, B is negative 11, C is negative 4. So AC is negative 12, so I know I have one of each sign. The fact that B is negative tells us the big absolute value is negative. So I'll make my little table for negative 12. Big guys get the negative, little guys get the positive. So 1 and negative 12. And we get it on our first try. There's our sum of negative 11. Now the fact that a was not worth 1 tells me I can't do the fast factoring anymore. So I'll have to hang on to this negative 5. Don't lose them. I'll hang on to the 3x squared. I'll hang on to the negative 4. But in between, instead of a minus 11x, I have a plus 1x and a minus 11, or a minus 12x. So negative 5 doesn't disappear. You keep it the whole time. 3x squared and 1x have x in common. Negative 12x and a negative 4 have a negative 4 in common. So I close both the parenthesis and the bracket. So negative 5 is still multiplied by this whole thing. You do need this second set. We can't have it attached just here, which is what we'd have if I didn't have those brackets there. Common factor, the 3x plus 1. So I'll hang on to the negative 5, hang on to the 3x plus 1, and I'm left with an x and a minus 4. Those come straight down. So there's our fully factored version. All right, couple of special cases to look at as well. Let's see, so we'll look at being asked to factor x squared plus 9x plus 2. So this is definitely quadratic. GCF is still 1. Plain boring 1. If it's not, fix it. We can identify A, B, and C. So A here is 1, B is 9, C is 2. Product, we're looking for A times C. 1 by 2 is 2, and a sum of 9. So product being positive tells me it's either plus plus or minus minus. Sum being a positive 9 tells me that it's plus plus. Here's the problem I run into on this one. The only sum I can get then is a 3. There's no way I'll get a 9 from that. This is an example of a quadratic that is prime. So not all quadratics are factorable. Some are not factorable. So just like factoring down 12, we had a big long list. 2, the only factors are 1 and 2, or -1, -2. Just like 2 is a prime number, this polynomial itself is also prime. It's not factorable. There's no way I can multiply to 2 and add to 9 using integers. A couple other special cases. So again, same request of factor. They want us to factor throughout this section. We'll look at x squared minus 25. So this is still a quadratic. Remember, it doesn't have to have all 3 terms to be quadratic. It just has to have an x squared with a coefficient that's something other than 0. The b can be 0, the c can be 0. That's okay. So here a is 1, b is 0, and c is -25. So our product, 1 times -25, -25, and we want a sum of 0. Well, hopefully you recognize that as being a -5 and a +5. -25 would have 1 of each sign. So -1, +25, or +1, -25. 5 and -5 gets the job done. Leading coefficient is 1, so we can do our fast factoring. So x plus 5 by x minus 5. We just bring those right along. We can do something similar if we look to factor 36x squared minus 49. We can even throw a second variable on it. Now here, I can identify a, b, and c. b here as 0. The easier way, though, to recognize is that this is that same idea of perfect square minus perfect square. So x squared is a perfect square, 25 is a perfect square, 36x squared, perfect square, 49y squared, perfect square. When that happens, we're always going to end up breaking it into the product of the sum and difference of the same 2 terms. So I can use a 6x and a 6x. That'll get me to 36x squared. 7y and a -7y. That'll get me to a -49y squared. And thinking of your foiling, the outside -42xy and the inside +42xy will cancel out. Watch out, though, if we don't have a minus. If they're asking us to factor, say, x squared plus 25 instead, now I'm looking to multiply to +25. And get a sum equal to 0. Well, some ways to factor 25, -1 and 25. 1 and -25, those won't give me zeros. I'm out of room here, so we'll continue in the next little column here. 5 and -5, that would add to 0, but that would multiply to a -25. I want a positive, so I can use positive and positive, but the sum there is 10. -5, -5. Product is 25, but the sum is -10. This is one of those impossible tasks. This is prime. So if it's a sum of perfect squares, it's prime. So watch out for that one. Sum of perfect squares, you're looking at a prime. Okay, so that should give you enough to practice both the 2-5 exercises And I'm also going to put up a PDF since the 2.5 exercise set was very lean. It was, I think, only 6 problems or so. I did create some supplemental exercises as well. So check for the PDF as well. You'll see that coming. If you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.